Okay, we have here today another integral from the MIT Integration Bee from 1991, problem 32. We have the integral of x to the fifth times e to the x dx. Okay, now to get started with this, I'm just noticing we've got two things and they don't really work particularly well together. So the only way I really know to do this is actually with integration by parts. So what I'm going to do is I'm going to do the DI method or tabular integration over here to the right. We'll have one thing to differentiate, one thing to integrate. I want to differentiate x to the fifth because it's going to get simpler and reduced the more times I differentiate. We'll have to differentiate it multiple times and then we'll just integrate e to the x. So then we'll have alternating signs here on the left and we're going to have a whole bunch of rows. So I don't know how many times. Let's just see. So let's just differentiate this. So this is going to be derivative of x to the fifth is going to be 5 x to the fourth. Derivative again is going to be 20 x cubed. Again is going to be 60 x squared. Again is going to be 120x. Then this one's going to be just 120 and the last one is just going to be 0. Then integrating down here, everything's going to be the same. Integral of e to the x is e to the x, so we can just copy that. I'll just draw an arrow and we'll just bring that all the way down. But then we don't have to worry about the last row being an integral just because we've got a 0 there. So that's going to 0 that out. And then here, let me just put in an e to the x there. So then we just need the diagonals and we'll just copy down all this stuff because this is going to be our solution. And of course, we've got an e to the x and everything, so I'll factor e to the x out front. And then I can basically just copy down everything here in the left columns. So this is going to give me x to the fifth minus 5x to the fourth plus 20x cubed minus, we'll just bring it over here, so minus 60x squared plus 120x minus 120. Add a plus c on the end, and that's it. Okay, so not really a lot going on. We just had to differentiate a bunch of times and write down the answer. So quick and easy problem from MIT 1991. Thanks everyone for watching. Have a good day.